This is scoposcopy. When does AC become DC? And does a sinusoidally changing voltage actually mean that you have AC, alternating current, or not? So here we have the diode array. We have one bank of diodes hooked up in that orientation, and another bank of diodes hooked up in that orientation. And they're dangling from the positive lead that goes to the function generator right now. And there's the negative lead, and I'll be hooking that up in a moment. The RM503 right now is tracing across the 0 baseline of the channel that we'll be using. Well, really, there's only one beam in this oscilloscope, so that's all you're going to get. So remember where that is. It's right in the center of the gradical, right? Okay, so now I'm going to go ahead and turn on the channel like that. Okay, now what you're seeing is a slow symmetrical sine wave. The channel setting is at 1 volt per division, and there's no attenuation. So there you're seeing a signal going from about 1, 2, 3, 1, 2, 3, going from a little bit over 3 volts positive to a little bit over 3 volts negative, positive, negative, positive, negative, right? And that's an alternating current signal, or it would be a current if there was current flowing, but there isn't because it's not hooked up yet. Okay, that's coming from the F43 over there. Okay, now what I'm going to do is I'm going to hook up the function generator to the diode array. Okay, just like that. All right. Okay, now notice what's happened to our nice sine wave. It's now decreased from its former peaks by a little bit, and it flattens out there. And you'll notice that on the red side it goes down a little bit further than it did on the green side. In other words, the decrease from 3.2 volts on the red side goes down to there. On the green side it only goes down to there. Okay, so what's going on here? Well, all these diodes are in parallel, of course. All the ones of the same color are all in parallel. Alright, so what you're seeing there is a voltage drop due to the forward voltage of all these diodes that's making the peak currents drop, or rather the peak voltages drop during the time that the diodes are on. And the difference in the drops from the peaks is because of the difference in the forward voltages between a green LED and a red LED. Okay, so notice what's going on here. The LEDs don't come on until the voltage is high enough to overcome that forward voltage, and then they come on. Alright, okay, so this is alternating current, right? The current is flowing in one direction and now it's flowing in the other direction when those LEDs come on. Right? So now what I'm going to do is use the function generator's offset control to vary the offset of that oscillation. Alright, so I'll put it set right. Alright, now I'm going to go up with it a little bit, or I'm sorry, down with it. Down, it's very sensitive control here. Alright, now you'll notice that we still have rising and falling voltages, right? But they never cross the 0 line. And the red LEDs, of course, don't come on, just the green ones when that voltage goes down far enough. This is not AC. This is direct current. It varies in magnitude, but it does not change in direction. Okay? It's a little bit less, then it's a little more, a little less, a little more, but it never crosses the 0 line, and it doesn't change direction, unless I take the function generator's offset control and I crank that offset the other way. Now we're crossing the zeros again, so the current is alternating. Now if I keep going to where we only have a positive offset, like that. Now the current is, or the voltage level is rising and falling in that same sinusoidal pattern, but it's not crossing the zero line. So the current is not changing direction. You could call this AC with a DC offset, but even that is not correct because there's no part of this that is actually AC. A simple AC with a DC offset would be something like this, if I can get it right. Alright, so here you have a negative excursion, but it's not sufficient enough to light those green LEDs. This is AC with a DC offset because the voltage changes sign right there, okay? This is AC, alternating current, with a DC offset. If you offset it even more so that the sign never changes, like this is no longer AC. It is not legitimate to call this AC with a DC offset because the DC offset is greater than the amplitude of the AC and has made it all direct current now. There's no part of this current that is reversing direction. Okay, so let's go back to zero offset on the function generator, and now we'll see this true alternating current going on. Thanks for watching. Let me unhook the LEDs so you can see that nice pure symmetrical sine wave. Thanks for watching.